Okay, so we're up to Chapter 9, Multi Area OSPF. So last week we looked at single area OSPF. It was our introduction to it all. So everything was in Area 0 for that. And so now we're going to look at having different interfaces on different areas. And so there'll be the core area, which will of course be Area 0, and we'll have a couple of other areas defined as well. And so we'll do that in both versions 2 and 3 of OSPF, or version IPv4 and IPv6. So we'll have a look at that. We'll look about some of the implications and how it works in the background, as well as how we actually implement. And so I did talk about it last week. So that is one advantage that OSPF has over any other, well, most other routing protocols. I suppose ISIS is accepted there because it does something very similar. So single area OSPF is great, but once it becomes a very big area, then the routing table gets very large. Your link state database can get very large. And the more networks you have, I suppose, the more chance there is that there's going to be networks going up and down. And so that's when your link state advertisements will be flowing around the network. And so the recalculation of the shortest path first tree will have to be done regularly. And as I said last week, it's not a trivial activity to run the algorithm. So it probably slows down the router and other aspects while it's doing that. And so to make OSPF more scalable, setting up in hierarchy will improve many of these problems. And so here they like using Area 51. I don't know, except their examples don't use Area 51, but yeah, the diagrams on this do. They might have to change it away if they do storm Area 51, and it's yeah. But anyway, so instead of having one large area for OSPF, you can divide it into smaller areas. Reduces the processing and memory overhead. And so, of course, you need to have a hierarchical network design. So again, getting back to Chapter 1, you can have a lot more benefits if you also have a hierarchical addressing scheme as well to go along with it. You can actually have summary IP routes that will decrease the size of the routing tables as well. And so the main area is the backbone area, which of course is Area 0. And so the advantages are you have smaller routing tables, fewer routing table entries as network addresses can be summarized between areas. And so because we've got areas, those borders between the areas become the defining sort of point where you do address summarization and the like. Reduce link state update overhead, because basically you only have to keep track of the database for within your area. So instead of it being that one big database with lots of networks that can change, there's going to be 3 separate databases, and no router will have all 3 of those databases, and so it will improve the utilization on the routers. Makes the trees smaller, makes the calculations, the running of the SPF algorithm less frequent, and on a smaller database means it will be quicker as well. So there's a whole pile of advantages like that. And so basically, as we said, the backbone area is Area 0, and all other areas are supposed to directly connect to that backbone area. So as you can see, Area 1 shares a router with Area 0, and some of the interfaces on that router will be in Area 1, others will be in Area 0, and of course that was Router 1, of course. On Router 2, it will actually, some interfaces will be part of Area 0, others will be part of Area 51. And so again, those 2 routers will have two databases on them, and so they'll actually be participating in both areas. so you'd probably want them to be maybe a slightly higher spec router, but again, it would still be less overhead for them than having that one big area. So regular areas, non-backbone areas, are where your users and resources will be connected, usually set up along functional or geographical groupings. All traffic from other areas must cross a transit area, so that's area 0. There are 4 different types of OSPF routers. So an internal router means all of the interfaces are in the same area, and so yeah, it's completely in area 0, area 1, whatever it might be. A backbone router, it means it's a member of area 0. An area border router, or ABR, is the router 1 and router 2 that you see on the diagram there. They're the border between area 1 and area 0, or area 0 and area 51. And so there's another type, which is autonomous system boundary router. And so that is where you would have your link to the internet. And so it's got an external route, typically, your default route to the rest of the world. And so basically, yeah. And so as soon as you have a default route and you advertise that to the other routers in OSPF, it will become an ASBR. Now, a router can be more of those things. As you can see, router 1 is an ASBR because it's got the link to the internet, but it's also an area border router because it's on the boundary between area 1 and area 0. It's also a backbone router because it's part of area 0. So it's actually 3 out of those 4 things. So when we were talking about LSAs last week, basically it was the top 5 that we were talking about as the types. So a router LSA, a network LSA, a summary LSA, and an external LSA. We didn't probably talk about that much. But basically, yeah, as soon as you start having multiple areas, you'll actually start using a whole pile extra types of LSAs. Now, you don't really need to worry too much about it unless maybe you're fault finding, but it's certainly good background information to have. So LSAs individually act as database records and provide specific OSPF network details. LSAs in combination describe the entire topology of the OSPF network or area. Any implementation of multi-area OSPF must support the first 5 LSAs. And so a type 1, and so as we saw from the previous page, that was a router LSA. And so a router LSA describes the router and all links that attach to it. And so it's also called a router link entries LSA. So the LSAs are flooded only within the area in which they originate. ABRs, advertiser networks, learn from Type 1 LSAs to other areas using Type 3 LSAs. The Type 1 LSA link ID is identified by the router ID of the originating router. And so from the diagram, Type 1 LSAs include a list of directly connected network prefixes and link types. All routers generate Type 1 LSAs. Type 1 LSAs are flooded within the area and do not propagate beyond an ABR. Type 1 LSA link ID is identified by the router ID. Yeah, so Type 2, they're the network LSAs, and so only found on multi-access and non-broadcast multi-access networks. So basically, it's where you can have more than 2 routers connected, and so you can describe all the routers that are connected to it. And so it contains the router ID and IP address of the DR, along with the router ID of all other routers on that multi-access segment. Give other routers information about multi-access networks within the same area, not forwarded outside of an area, also referred to as network link entries. Link state ID, again, is the DR router for that multi-access network. So Type 3s are used by ABRs to advertise networks from other areas. And so I think it was a summary LSA. So it creates the ABR creates a Type 3 LSA for each of its learned OSPF networks. ABRs flood Type 3 LSAs from one area to other areas. To reduce the impact of flooding on a large OSPF deployment, configuration of manual route summarisation on the ABR is recommended. Link state ID is set to the network address. Now we'll actually talk about summary routes next week. That's chapter 10. So Type 4 LSAs are from ASBRs, and so this is basically the external routes that it's advertising. They are generated by an ABR only when an ASBR exists within an area. So in this case, we've got this ASBR here that's connected to the internet. It's not an ABR in this case, and so basically the ABR will then advertise that external link as a Type 4 to the rest of the areas. They are flooded to other areas by ABRs. The link state ID is set to the ASBR router ID. And so the last one, Type 5, they advertise external routes, also referred to as external LSA entries. They are originated by the ASBR and flooded to the entire routing domain. And so basically, yeah, this is the actual route information, while the previous one was about which was the ASBR. And the link state ID is the external network number. Okay, so when you have multi-area OSPF, you will have some extra types of entries. And so, as you can see, we've got OIA, and then you've got OE1 or OE2, depending on what type of external route. And so, as you can see here, we've got the external route here, and so that's our default route, and so that's why we've got the gateway of last resort entry up there. And we've got these IAs, which of course means it's inter-area, so it's from a different area. So if router 1 belongs to area 1, any networks learned from area 0 or area 51 would actually be OIA entries. So of course this E2 in this case was created by the ASBR, wherever that might be. On the other side of serial 000 at least. Okay, so basically when it comes to route calculation, all routers calculate the best path or paths to destinations within their area. And so the database that they use only is from within the area they belong to. All routers calculate the best path or paths to the other areas within the network by using the Type 3 LSAs that have been advertised. All routers calculate the best path to the external autonomous systems as well. So those E1 or E2 links. And so basically, as I said, the database only describes within the area. The rest of it is just extra information that they use. And so, as you can see here, we've got the intra-area routes here. We've got OSPF routes from within the area. And we've also got that external route. Okay, so how do we configure it? It ain't tough. So, of course, the first step is always to have a plan. Don't just do it and hope for the best. You should have a plan. And so from there, you should actually define the OSPF parameters. And so again, that plan should be how the addressing will work. Ideally with OSPF, you would do a route summarization at ABR boundaries. What areas will you have? What routers will be used as the ABRs? And what network topology will you have? And so from there, you configure it. And then, of course, after that, you verify it. And so how do we configure it? Not greatly different. Basically, the major difference is not everything's going to be area 0. It's going to have some links that are area 1. And that's about it. And so it's not particularly special, just you need to have an understanding how it works. And so this topology here is what I've actually configured for the demo I'm going to do a bit later. And so we've got 3 routers and we've got 3 areas. And so we've got area 0, the backbone area. And so all 3 routers are actually a member of the backbone area. And then we're going to have an area 1 and an area 2. I'm going to say this is too trivial to really require a multi area OSPF. But of course, it's just demoing how you would do it. So what was on? Was there a screenshot on the previous one? Yeah, so basically we're just the network commands for router 1. Of course, this is OSPF version 3, so IPv6. And so again, we just define OSPF, give it a router ID, and then we go to each individual interface. Now, for some reason I've changed the number of Ethernet interfaces on this compared to that, so I've basically ignored 2 from the previous diagram in the demo I've got. And so how do we verify it? So show IP OSPF neighbor by all means. Show IP OSPF interfaces isn't bad. Show IP protocols is always good. Of course, show IP route. That's always useful. Of course, the OSPF on the end means it will only show you the routes learnt from OSPF. And of course, you can look at the database as well, but that's really, to me personally, show IP OSPF neighbor, show IP protocols, and show IP route are the 3 major ones I'll look at. If I'm happy with those 3, I'll get on with my life. If not, that's when I might start looking at the others. So, all right, what is going wrong? And so, normally, how have I screwed up? And so, of course, show IP protocols will give you the information, and it actually shows you which networks are in which area. It also tells you the number of areas, and so we've got 2 normal areas. Show IP OSPF interface brief. Again, shows you the 3 interfaces that are participating OSPF, what area they belong to. That's certainly not bad information. And show IP route OSPF, of course, just gives you the routes learnt from OSPF. And you can look at the database, of course. And so you can actually see your router link states, your summary network link states. And so this is on router 1. And so, yes, it's got area 0 and area 1. So it's actually got 2 databases, as you can see. Now, of course, normally it won't be color-coded. Someone's done that for the screenshot, for the PowerPoint. But basically, you just start looking at the area numbers here, and that will explain it to you. And so, of course, how do we verify it in IPv6? Exactly the same. It's just IPv6 instead of IP. And so, again, your intra-area networks will have OI. Protocols shows you which interfaces are in which area. IP brief, interface brief, of course, gives you the interfaces and their areas. Okay, so that's the summary. So we're nearly finished. So we've looked at multi-area OSPF and how it operates, and then we've looked at how we implement that. And so we have a logo.